Model rockets are smaller versions of real rockets, and they use many of the same principles to fly. Model rockets are powered by a small motor that provides the thrust needed to make the rocket launch. Model rockets use what are known as solid rocket motors to fly, similar to what was used on the Space Shuttle and now the Space Launch System. Most other rockets use liquid-fueled engines. In liquid rockets, they mix two liquid parts together in a very complex engine. These two parts are the rocket fuel and the oxidizer, which when mixed together and ignited in the engine make a very powerful combustion or controlled explosion. Solid rockets have these fuels pre-mixed in a kind of waxy mixture, making them very simple. Solid rocket motors' simplicity makes it possible for anyone to make and fly their own model rocket. In amateur rocketry, these are referred to as rocket motors or just motors. When the motor is ignited, the solid mixture burns, producing a hot and high-pressure gas. This gas is expelled out of the engine very fast, producing thrust that propels the rocket upward. After all of the rocket fuel is burned, the motor stops producing thrust, and the model rocket will no longer be gaining speed. This is called motor burnout, the point where the rocket motor stops burning. After motor burnout, there is a part of the motor called a delay grain that starts burning very slowly. When the delay grain is fully burnt through, it hits the ejection charge, a small amount of black powder that burns and makes a high-pressure gas inside the rocket. This ejection charge gas forces the rocket to separate and pushes the parachute out. A lot of the time, you will use the ejection charge that comes built into the motor, but in high-power rocketry, separate computer-controlled ejection charges are common. The speed of the model rocket is determined by the amount of thrust produced by the engine. The more thrust produced, the faster the rocket will move. However, a lot more goes into the speed of a model rocket, including the size of the rocket motor compared to the size of the rocket. If you put too small of a rocket motor, it might not even leave the ground. Generally, the faster a rocket goes, the higher it will go. However, gravity will always be pulling the rocket down. And after the motor burnout, it's only a matter of time until the rocket reaches its highest point. The highest point of a rocket's flight is called the apogee. Another important factor in model rocket flight is aerodynamics. The shape of the body of a model rocket is carefully designed to minimize air resistance or drag. This allows the rocket to fly more efficiently and reach higher altitudes. The fins on the body of the model rocket are used to stabilize the rocket in flight by cutting through the air and keeping the rocket from tumbling. The fin shape can be designed to create less drag, further increasing the apogee of your rocket. To make sure model rockets are safe, strict safety guidelines must be followed when launching them. This includes making sure that the launch site is clear of people and obstacles, and that the rocket is pointing straight up into the sky. It's also important to make sure that the engine is the correct size for the size of the model rocket, and that the rocket is not overloaded with extra weight. In conclusion, model rockets use many of the same principles as real rockets to fly. By understanding the basics of how model rockets work, we can see just how amazing and complex this technology can be and learn a lot about physics. Just remember to always follow the safety guidelines and have fun.